Oh, Joseph. So yesterday we talked about what the generic exponential growth and decay graph looked like. Today we're going to talk about applications. And I'm going to say children enjoy this lesson. I don't necessarily know if that's too strong of a word, though. So applications we know means secret talk for story problems, but they involve things like you want to talk about, like money and bacteria. Who doesn't like a good bacteria question? So let's talk about, this is a lot of words, guys. If you have a highlighter, you might want to get it out. So I see some important information here. There's a formula. This is the same formula that we've been looking at, but they've separated out the pieces. Now, if I keep looking down the page, or that paragraph at least, there's another formula, and both of these can be used to represent real-life quantities that increase or decrease at an exponential rate. But what's the big difference between those formulas? Can you tell? Yeah, one has 1 plus r and the other one has 1 minus r. So this would be the one that you would use if you have a situation where there's exponential growth. Something is gaining money or increasing in some way. And then this one you would be using if you have natural exponential decay. So things that are dying off, populations are decreasing, or maybe your amount of money is decreasing. That'd be sad. So there's a lot of information in here if you look carefully. So the first thing they tell you is that A is the initial amount. So you'll notice in both of the formulas, there's this letter A in front of the parentheses. That's always going to be the starting amount, the initial amount. And I kind of covered it up halfway, but it does say right here, R is the percent in decimal form. So just so we don't have an awkward moment later, if you have 25% and your teacher wants you to write it as a decimal, what does that look like? 0.25. And what about like 4%? What does that look like as a decimal? 0.04. So those of you who know how to get that answer really quickly, can you tell your friends? Okay, so some of you are fans of just moving the decimal point over 2 spaces. So you move it over once, twice. Same thing here, but in this case you had to put a filler 0. The mathematical way to come up with a decimal version is just to divide the number by 100. So 25 divided by 100 is 0.25. So if you know that you personally struggle with getting the right decimal value, because this is a big issue for kids, they put, like for instance here, a lot of kids put 0.4. Well, what's 0.4 represent? 40%, which is a much larger increase than what you were intending. So you got to be careful. Anywho, let's keep reading. T is time. No shock there. It does say in years. That's kind of a lie. Sometimes they don't measure them in years. It depends on the problem. Like bacteria. The next question is about bacteria. You're not going to let bacteria sit around for years. That's disgusting. So let's talk about this question. We have a science who's estimating the amount of bacteria that's in this collection. And it starts with 730 bacteria. So this is that starting value, which they kept calling A in the formula, lowercase a. And then it says that the specimen is growing. So are we going to use the 1 plus r or the 1 minus r version of this formula if it's growing? 1 plus r. And then 35%, better written as 0.35. And it grows every minute, 35%. So that's gross. And this is classic science. I don't know, those of you in science class, if you've seen them do this. They'll take a formula, and then they'll be like, yeah, you know what? I'm just going to change variables for no reason whatsoever. So like our equation started with y equals, and then down here they're like a equals, like a capital A, which is different than lowercase a. So if that bothers you, just change that to a y. So what they want you to do here is create a model, write an equation. They don't actually want you to calculate anything. So you're just going to put the numbers where they belong in the formula. So what was our starting value? 730 bacteria. And then you guys told me we should be using the growth formula because it's growing in population. So 1 plus, your rate was 0.35. And then for a generic model, you don't know the time. So you're going to leave time as a variable. You can either use x or you can use t if you want to be fancy. We're about to use a calculator though, so I'm going to stick with x. So this is the general model that can represent the amount of bacteria at any time that the scientist wants to do a calculation. So this next question, the scientist wants to know how much time will pass for the bacteria to reach a population of 9,000. So they don't know time, right? This is a question mark for time. What that means for me as an Algebra 2 student is I'm going to use my table. Please write that down in your notes. Because you're looking for time, you're going to use your table. So everybody with me on their calculator, you're going to go to Y1, and you're going to program in this general formula. And you don't even have to simplify it. Your calculator doesn't care if you simplify it even. Make sure that you have x up in the exponent position. And then I'm going to get mine typed in as well. Now your table should be set up in autofill mode. If it's not, we can change that. Okay. So this is going to show us the population of the bacteria at any given time, X minutes from when we started the timer. If you go to your table, guys, everybody, second table. Now, anybody have a cute person who had your calculator earlier and they scrolled to like 1,000 or something? I had that happen in the other class. Yeah, don't do that, by the way. But if you haven't reset your calculator and the kid before you did something goofy, you can always go to table set, which is second window, and then just make your table start at a more appropriate number, like 0. There's always some jerk in some class who does something weird. Sorry. You know who you are, kid. All right, so second trace. Here's your table. I want to know when the population reaches 9,000. You're not going to be able to get an exact answer, but we're going to get a good enough answer for Algebra 2. Can you tell if you kind of scroll down a little bit? Right here, right? So between here and here, it would have hit 9,000. So what we're going to tell our reader is between 8 and 9 minutes, and that's a good enough answer for Algebra 2. So 8 to 9 minutes. And the only reason I knew it was labeling in minutes is because it literally said minutes in the question, how many minutes, and it also said up here that the population gains 35% every minute. So that's a good use of our calculator, and that's why we're going to not be giving you homework on these questions. This is all going to be done in class. Was there another part to that question? That was it? Okay. Oh, now we're going to buy a car. So I don't know how many cars you guys have bought. Did you know that they depreciate in value incredibly quickly? Like you drive them off the lot and they are no longer worth anywhere close to what you bought them for, if they're new. So you bought a car for $36,000. That's the initial value. That's like the lowercase a. And this time we have a decreasing by 14%. So because it's decreasing in value, you're going to use this formula up here where it has 1 minus r. And speaking of r, what is our rate written as a decimal? 0.14. Very good. So first question says, write the model. They just want the equation. All right, y equals, what was that initial amount for the car? How much initially was it worth? 36,000. And then in the parentheses, you guys told me to use the 1 minus r formula because it's depreciating. So 1 minus 0.14. And then for the general model, don't use anything for time other than a variable. So this is the model. This is the general form. We're going to use that general form for the next 2 questions. So question B, estimate the value after 3 years. They're just flat out saying plug in 3 for the time. Because they give you time, we're going to use your home screen. Please write this down on your notes. When they give you time, you should be in the home screen. So in the home screen of your calculator, you're going to type 36,000, 1 minus 0.14, and then raise that up to the 3rd power because they want 3 years to go by. And this is a money question, so I also want you guys to be intuitive about your rounding. You want to round to the appropriate amount for money, which would be the hundredths place because of change. You should get like 22,000 something. Excuse me. You stretching? And you guys are in the home screen right now? Just the general calculation screen? You're not in your table or anything goofy like that? Can I steal the number from somebody? I don't have that written down. 22,000. 898. And what's the change? It's just 0, 1? Oh, it rounds up to 2? Okay. I was like, I've not heard that question or that answer today, so I was getting nervous. All right, so car's worth, 23,000-ish, but there's the exact answer off our calculator. Now the next question, they want you to graph, but I'm not going to graph. We're going to use our table. We're going to estimate when the car is worth $15,000. So because I don't know time, that's why we're using the table. So this time you do have to go to Y1, and you're going to program your calculator with the general formula, the 36,000, 1 minus 0.14. But remember, time is not 3 years anymore. Time is unknown, so you're going to use x up in the exponent. So we're going to be using a lot of technology in these questions, and part of the issue is you have to know how to use your technology. That's actually what I'm testing you on. Once you get your function typed into Y1, you're going to scroll through your table, and it's not going to be an exact answer, guys, but you're going to look for an approximate time for where it hits about $15,000, because apparently I want to sell the car at that point. Between 5 and 6 years is what I'm hearing, yeah. Okay. So the big idea so far today is that we can create models, and then if I don't know time, if I'm trying to figure out how much time has gone by, I should be using my table on my calculator. But if they flat out give me time, like in example B there, I just plug it in my home screen. All right. This next one doesn't involve a calculator at all. So I gave you the formula, and I want you to interpret pieces of that formula. That's the question here. There you go. So we have an antique table who, ever since 1975, has increased in value because antiques actually gain value. So the question I have for you is, what is the value of the table in 1975? This is like the birth of the table. This is when it was, at least the value of it started going up. So what was the original amount of the table is what they're asking you. Which one of the numbers in the formula is that? The 325. Very good. So they're asking you to identify that initial value is the price of the table in 1975. This next question, I wonder if you can pull the percentage out of the formula. Can you tell me what it's growing at? What percent? It is 3%. Can we talk about that? So in the formula here, remember this parenthesis is really 1 plus r. So if you see 1.03, that means that decimal component to it was 0.03, which you can write as 3%. Now, if you wrote 0.03, I'm totally okay with that. I understand what you're saying. But I've seen kids do this, 0.03%. How do you feel about that? Is that the same thing as 3%? That's teeny tiny. That's like 0.0003. So, no. Don't do both of them. Okay. All right, here's the fun one. And you have savings accounts? Good. You should save your money. It's good. I have a savings account. How much percent interest do you get on your savings account? Like nothing. It's like less than 1%. Yeah, it's not very much. So first of all, I want to warn you that these questions, they seem really cool. Like, wow, I could really make a lot of money if I just put my money in a savings account. No. These savings accounts, they're made up. They don't exist. You are not going to find a savings account that pays you 8% interest. That's not a thing. But if they take interest from you, I can guarantee you it could be 8%. Like your home loan interest could be 4, 5, 6, 7, 8%. Your student loan interest is 8-ish%. Yeah. But they're not going to pay you 8%. So that's lame. But that's the way the world works. Okay. So what happens with your savings account typically is they pay you out quarterly for most banks. But there's other ways they could pay you. So quarterly means every quarter they give you a little installment of a payment. And they build up your balance in your bank account. So why is that better than just getting like one lump sum at the end of the year? Well, they're going to give you a little bit of money in, March, and then a little bit of money in, I can do the calendar, hold on, June. And then they're going to keep giving you little bits of money as the months go by. Well, while you've collected a teensy bit of money, you've increased your overall balance. So when you collect your next interest payment, you have even more money. It builds upon itself, and that's why we see this exponential growth factor. So let's talk about this formula, because this looks like a hot mess. It actually is very closely related to the one you guys were just looking at, but they've added this value of n to the formula, which represents how many times you're going to collect interest every year. So, have you heard words like quarterly before? And you know what monthly means. Semi-annually? Okay. So those are things that they're trying to ask you, like how many times do you collect interest every year? So this particular question, we have $1,000 that were thrown into the bank account, and they call that number the principal when it's associated with money. It still gets stuck right in front of the parenthesis where it was on the last formula. It's really the same formula. And then in the parentheses, you see 1 plus r. That's the same thing as your original rate that you were using in the last formula, but you're going to divide it by n. So with that quarterly installment we were just talking about, they don't give you all of your interest every quarter. They just give you like a little fraction of your interest every quarter. And then up in the exponent, instead of just time, it gets multiplied by n as well, because you get paid every single quarter. So if you let your bank account sit around for 10 years, you got paid every quarter for 10 years. You got paid 4 times 10, 40 times. So that's how the formula works out. But let's get around this, guys. Annually, how many times a year does annually? What's that? What are they talking about here? 1 time, yeah. Quarterly? 4 times. And daily? We'll go with 365. Technically, we know that's not true. There's not technically 365 days in a year, but that's okay. Leap year, man. It's 365 in a quarter or whatever it is. No. It's not quite right. Let's just argue 365. Anywho, we're going to be working in our home screen on this problem, so you might want to write your little note here. And they're going to keep changing the n, and you're going to see how that affects your bank balance. So we're depositing $1,000, and then we're in La La Land apparently, and we get 8% interest. Not quite. And this is kind of stupid. You're only going to leave your money in for 1 year. So your time's just going to be a 1, which is really quite lame, but that's okay. All right, so here's how our formula is going to work. Write it down on your paper, and then we'll go to the calculator and type once we have it all written down. You start with the $1,000. And then we got 1 plus, now your rate, remember, was 8%, but you got to write that as a decimal, so that's 0.08. You're supposed to divide it by how many times you collect interest. So in this question, annually means you collect it once. And then up in the exponent here, that 1 shows up again, and you're supposed to multiply it by how many years you leave it in the bank, and you're only leaving it in for 1 year. Now, if you're using an older calculator, not the color screen ones, you're also going to have to put parentheses around this 1 times 1 thing when we get to the next question, and the next question, and the next question. But the newer calculators, you don't have to have these parentheses because it stays up in the exponent position. All right, could y'all type that in your home screen for me? Tell me how much money we have in the bank account after 1 year. $1,080. So how much interest did you collect? $80. Just for letting your money sit around. That was pretty nice. And also not realistic. Okay, so the next question. Yeah, if we redid that question with like the fraction of a percent you get, yeah, you don't get very much money. All right, so now we're going to collect monthly, instead of annually, we're going to collect quarterly. So the only thing we're going to change is all the n's change to 4s. So it's still $1,000. And it's still 8%. But you're going to divide that by 4 because of the quarters. And then up in the exponent, that also changes to a 4. Still for 1 year, though. Now how much money you have? It's got to be more. You're collecting interest three more times. It's not very much more. It's like 1,082 something. What's the change on that? 43 cents? Okay. So like $2.50 more. But, you know, more is more. So if everything else is the same, like obviously I'm going to put my money where I get more money. So daily. What if they let you collect interest daily? This has to be better, right? 365 times. Let's find out. Let's do the math. So the n this time is changing to 365 in both places in the formula. Still for 1 year. And how much glorious money are you rolling in now? Yeah, not very impressive. 1,083 and what's the change on that? 28 cents. Every penny counts, guys. Count them. So why did that happen? Because, I mean, usually when kids look at that problem, they're like, oh, for sure, the daily one is going to give me tons of money. Because they envision getting all this money. Like, every single day, your bank pays you money. But are they paying you your full interest amount every day? January 1st, they give you, like, this tiny fraction of a penny. And then January 2nd, they give you, like, a slightly larger fraction of the penny. And then January 3rd. So you just get, like, teeny, teeny, teeny amounts. It does end up building upon itself. What could we do to make more money? What if I wasn't happy with this $83 in interest? Okay, we would see a much bigger difference if we invested more money. If we invested $10,000, we'd be talking a much bigger difference between the 3 bank accounts. What else could we do? Yeah? So without changing the amount of money, what if I was like, $1,000, that's all I got? If I had to do bank with a higher interest rate. In Disneyland, perhaps. What else? Yeah, we only left it in for a year. You want miracles to happen in a year? No, you gotta let it sit for a while. That's why grandma opens that bank account when you're a baby, and then you go to college, all of a sudden you got all that money. It's beautiful. Turns out college costs 5 times that amount, but that's okay. Dang. So we don't have any homework on this. We're going to continue working on this tomorrow, and then your homework will be done in class tomorrow. So obviously attendance is necessary, and when we do have class time, like you guys did a good job today, continue to use it tomorrow. Thanks.